Good morning. Can you see my slide?
Yes, ma'am, it's visible.
Okay, great. Let me just do a little bit of adjustment. Okay. Right. Assalamualaikum and very good morning to everyone. I'm Professor Dr. Intan Darus from University Technology Malaysia. And today I would like to talk a little bit about my research on intelligent automation and robotics. Okay, so I'm from Malaysia. This is University Technology Malaysia. Just a little bit of introduction on where is University Technology Malaysia. If you have been in Malaysia, it is on the southern region of Malaysia, Johor Bahru. So it's very close to Singapore, our main campus. We have another campus in Kuala Lumpur, the capital city of Malaysia as well. Okay, so UTM is actually Asia top university. Is a young university. It's established in 1972. It's a research university, and our recent latest vice chancellor is Professor Datuk Ahmad Fauzi Ismail. He's actually a very prominent professor in membrane technology. We have around 1,407 academic staff with PhD, and our postgraduate students in research is actually 11,182 students. So we also have international student and local student. For our undergraduate is about 13,700 students we have currently in UTM. So just a little bit of introduction related to my university. Okay, this is the content of presentation that we'll talk today. I'll talk a little bit about Industrial Revolution 4.0, some robotic classification, artificial intelligence, and how to implement intelligent control for robotics. And also I will share with you my current and future direction in research. Right, so as we all know, Industrial Revolution 4.0 have merged in maybe early 1990s. Okay, so where does it come from? It is actually started back in 18th century, where we have revolutions of 1.0, where mechanical equipment is being used, okay, for the industry, and then we have Industry 2.0, where mass production of assembly is actually utilizing electrical energy. And then later on we have Industrial Revolution 3.0, which maybe we did not realize, isn't it? We have all these, okay? So where automated products are using electronics and IT. So what is the difference with Industrial Revolution 4.0? At the moment when we talk about IR 4.0, it is actually utilizing intelligent productions incorporated with IoT, Internet of Things, cloud technology, big data, and all this artificial intelligence. Okay, so this is the difference between Industrial Revolution 1, 2, 3, and 4. Okay, so actually for your information, we are actually we are going towards Industrial Revolution 5.0 now, where humanizing of the technology is actually part of the IR 5.0. Right, so if you talk about IR 4.0, it is actually referred to the convergence of applicant of 9 digital industrial technology that you can see in this slide. We have artificial intelligence, augmented reality, additive manufacturing simulation, cloud computing, autonomous robots, system integration, and many more. Okay, so the use of interconnected digital and associated technology in this industrial production that enable transformation of in terms of people, process, and technology to enhance the efficiency, productivity, and revenue of any productions. Okay, so this is what IR 4.0 all about. Okay, so if you talk about robots, I can just show you, this is a simple general classification of robot, where we can have robot or robotic devices as industrial robot or non-industrial robot that is actually very famous now. Okay, it's a machine that actually resembling a human being and able to replicate certain motion, movement, and also function automatically. So this is what a robot in general Okay, so if I shown you the classification that we can have at the moment, okay, robot can have maybe in terms of industry, it can be used for welding, painting, ironing, and assembly. So in a greater scale, in a bigger scale, where high endurance, speed, and precision is required, where human may be lacking in it. Okay. For service robot, you have seen domestic use. We have, for example, lawn mowing. You have a vacuum cleaner robot. You have a robotic being used in your equipment in daily activities. Okay, so professional use also we have a lot of robotic actually being utilized, especially during this COVID-19. We actually deploy robots to actually taking care of a lot of things. For example, for the sanitization in the area where it is very dangerous for human to go, okay, because of the spreading of virus and all. So we have it also for defense. We have robot professional use in terms of surveillance. Okay, so we can actually utilize this robot to help our daily activity, where it is actually will do a lot of precision and also require endurance. Okay, so I'm going to introduce another classification, which is what we call educational robot. This is also very important because currently our children actually being educated during their even secondary or primary school. They are being educated on how to utilize or how to actually use robot, because to make them very ready for the future, because the future is a robotic. You cannot deny the usage of robots. So we want to educate our children in the early years, so that they are actually very knowledgeable on it. Okay, so we do have also educational robot for in the industry at the moment. If you talk about artificial intelligence, we have actually used artificial intelligence in our daily activities. Our artificial algorithms enable the robot it's like a brain to your robot, to enable or to reassemble human motions and ability to replicate human functionality. So it's like the brain of your robot. Okay, so if I can simply characterize the artificial intelligence in terms of machine learning, expert computational intelligence, and distributed artificial intelligence, and many more. So okay, this is a basic of the distribution or the classification of artificial intelligence. So if I go in greater details, okay, so in the research field, when we talk about artificial intelligence, there are a lot of things like, for example, machine learning, computer vision, planning and guidance, and robotic structures being used. Artificial intelligence is being used in this field. We also have research technique utilizing artificial intelligence on, well known as AI, is, for example, artificial neural networks, evolutionary algorithms, evolutionary computings, expert system, fuzzy logics, genetic algorithm is actually very, very old algorithms being developed, and many more. Okay, so this is a part of artificial intelligence. So if I talk about the roadmap or the merging of artificial intelligence, it is started back in 1950s with the birth of our genetic algorithm, okay, many years ago, like maybe 70 years ago. Okay, so this is the early stage where artificial intelligence become merging of artificial intelligence. Okay, and then later on is actually being utilized as what I mentioned just now, the brain of robot, the brain of automation. Okay, when we have machine learning, okay, so when machine learning start to flourish, so the artificial intelligence is being used as algorithm to make decision, for example. And later this year, we've seen the merge of deep learning, okay, where it's actually similar to neural network. Only thing is that it is actually deeper in terms of learning. Okay, maybe some information that is not being taught, also they can actually make a little bit of learning there, so that it can actually function like a human brain. Right. So I want to talk about intelligent control and robotic and automations now. So in terms of my research, and I think most of our researchers that work in artificial intelligence, these are the basic research methodology that they employ. For example, when they want to actually conduct design controllers, so what they have to do in the beginning, the step is actually to do data acquisition first. So you either collect data of actual system from the experimental rig or from real cases, real implementation, cases from the factory, for example. Okay, so from this, utilizing this real data, we can actually then use it for system identification to model the system. All right, so the system may be not as simple as a linear system, because if it's very simple, then you can just use mathematical modeling, isn't it? Okay, for a very complex system, you're utilizing system identification, and artificial intelligence can be part of the algorithm to do this. I will show it in a minute. Okay, so later on, using the system identification, the model developed using system identification, we will then develop the controller. So the controller can be used conventional or intelligence method, but the controller development require you to have the model of the system first, which you can obtain using the second step, which is system identification. Later on, when you have developed the controller, of course, you need to validate the controller. So normally what we do is we're going to validate the controller in the experimental validation, so that we are very confident with the performance of the controller. And we can also validate it in a simulator, for example, in a real plant. Sometimes in the factory, you've seen the bigger plant, and they will have a small simulator to actually simulate the way the plant is actually behaving. So we can actually implement the controller that you have developed in simulation into this simulator, so that you will have a sort of a trust on the algorithm that you have developed. Okay. So in terms of my research, in the beginning, when we talk about robot, flexible beam is actually a very, very basic structure of a robot. So I'm not talking about rigid beam, we are talking about flexible. So when we talk about flexible, it is not only asking you to design the controller to move it, for example, but also to cancel the vibration that the flexible robot will have, will actually experience. Okay, so why flexible? Because if you talk about the huge robot, it is rigid and it is very, very heavy, isn't it? For flexible robot, it is very light. So when it is very light, it will actually experiencing vibration. So we need to actually design some controller to actually cancelling this vibration, suppressing this vibration. So this is the beginning of my research on developing the robotic structure. So we start with a very simple, back in 2010, 2012, we developed a very simple robotic structure on flexible beam utilizing aluminium beam. Okay, and then we have this smart sensor, piezo sensors and piezo actuators, and then we design a controller using artificial intelligence. I will show you the algorithms later on. Okay, so this is the basic of it. Then we are able to actually cancel the vibration. This is very important. Okay, this is some of the findings when we actually employ artificial intelligence in our active vibration control. So actually the controller, the basic controller, for example, we are using PID, proportional integral derivative controller, but the controller is able to be self-tuned, and we are using artificial intelligence to self-tune the PID controller. Why do you need it to be self-tuned? Because if you talk about robotic structure, okay, it can actually experiencing a lot of disturbance, of course, but the performance of the controller will reduce if the transfer function or the parameter of the system changes. So in terms of robotic structure, the parameter of the system always changes. Why? Because robot is actually holding things, isn't it? So the mass of your robot arm can always change. So when it changes, you want your controller to be updated so that the changes can be actually updated in your controller so that the performance is always optimum. Okay, so this is what we did for our vibration control on flexible structure. We later talk about flexible beam as well. So we've done it with plate. So with beam, why not with plate? Why? Because plate can be used. You need to have, for example, this structure it being utilized in many applications, for example, in robot, in the medical purposes, for example. All right, when you have this, for example, if you look at this horizontal plate, all right, so when you have a medical surgeon, for example, conducting surgery for a very long time, what happens is that they start to shake, isn't it? So we want to reduce this, because surgeons sometimes they do their surgery for a very long time, maybe more than 2 hours. So they are also human, isn't it? So what happens is that they will start to shake. So if we can have a sort of arm rest for them, okay, so this arm rest can actually cancel the vibration coming from the surgeon, for example. This is just an example. Okay, there are many applications, robotic structure that require you to cancel the vibrations on the robot structure that are looking like a flexible plate like we have here. So we've designed a sort of controller utilizing artificial intelligence to cancel the vibration, and it is actually very, very good because the vibration can be cancelled very fast. Okay. All right, there are many applications on robotic manipulator. As you can see, I've mentioned about medical purposes. There are service robot now actually serving people in the restaurant. You have robotic structure being used in the aerospace, okay, in agriculture, in plant development, and there are many applications that is actually very hostile for human, for example, to go and to do this kind of work. So robot being employed. So when we talk about robotic manipulator, maybe if you talk about robotic arm, it is actually very complex, isn't it? You look at it as if it's a very complex system. So we start with a very simple structure. Again, I introduce a flexible robot because, as I mentioned, flexible robot is very light, so it can be used. It can be used at many applications. Okay, so we develop a simple robotic manipulator like this. Okay, the purpose is not really to actually have it to do a lot of work. It's just to make it move, mimicking the robotic arm, and then utilizing flexible structure because we want to have it vibrate. So when it vibrates, our responsibility is to do the vibration control to cancel the vibration. So this is the kind of intelligence robotic manipulator that we have designed, and then we actually the purpose is not for us to develop the manipulator, but actually to develop with a very good controller so that it can actually control the very strong vibration experienced by this robotic manipulator, so that the robot can still function at the top performance of the functions. Okay, so when we talk about artificial intelligence algorithm for system identification and control, these are the kind of algorithm that we have utilized as well as genetic algorithms, okay, fuzzy logics, neural network. We have done differential evolution. We have gone through a particle swarm optimization, artificial beast colony, fireflies, and there are many more new algorithms start to merge, okay, and taken place for us to use it for system identification and also for controller. So these are some of the algorithms that we have used for our structure that I have mentioned just now. This is some of the result that I can show you for manipulator utilizing neural networks, okay, as an example, right? So we have this here. You can see the neurocontroller to do the system identification, and also later on, or you can see that we utilize it for control behavior as well. You can see the performance being actually is being identified very accurately with a very minimum error, so that the model can be very accurate. Okay, so this is what I have for endpoint acceleration. As you can see, the time limit here is actually very small, very millisecond. We are talking about millisecond, and yet the algorithm able to predict the vibration very accurately with a very minimum error, so that the model that we develop is very accurate. Okay, so this is a kind of a controller that we use. For example, I'm using a simple PID, but as I mentioned, the PID is being updated or being tuned using artificial intelligence. This is one of the applications that we use. Okay, so this is an example of the result on the hub angle of the two links. Okay, the first link of my robotic arm, okay, and then the second link of the robotic arm, to conduct a very simple motion just to move from 0 to 0.3 radian per radian. Okay, for example, all right, and you can see that it is actually performing very well and very fast. Okay, and this is the result of endpoint acceleration. You can see with the controller, all right, the vibration being cancelled very accurately. All right, okay, so what is the current and next directions of the research? We are actually in this, as everybody actually experienced, the 2020 is a very, very challenging years for all of us in the education, isn't it? We are experiencing pandemic that not allowing most of our students to come to the school or come to the university to conduct their usual classes. So what we have is actually we conducting education or our classes through online session like what we have here. Okay, so for lecture, normal lecture is quite simple, quite straightforward. We can just use WebEx, Zoom, or Google Meet, and we can meet our student all the time at anywhere, anytime. But how about laboratory work? So some of our students, for example, for mechanical engineering, in my school is mechanical engineering, we are having this difficulty because students need to actually utilize the experimental work, experimental equipment that is actually in the lab, isn't it? So university is closed because they are not allowed to enter the university because of the pandemic. So what happened is that we come up with a research, we quickly come up with a remote laboratory educational robotic arm where our student can actually assess the behavior, the robotic arm from wherever they are. So we're developing educational robotic arm with intelligent controller, and it is remote assessed by people from all over the world. So this is actually one of current research that we are doing, is still under research. Okay, so the purpose is actually for anybody who would like to use the robotic structure. They can actually design their controller from anywhere, and then they can assess our robotic arm, okay, to actually test their controller, and they can use their data to analyze the performance of the controller. So without even having to buy the robotic arm. As you know, robotic arm can be very expensive, isn't it? So this is actually a medium where we can actually let our system to be rent, for example, for people from all over the world to use it from anywhere they are. So utilizing remote monitoring and remote programming, so they can actually conduct their program using MATLAB or LabVIEW or whatever, okay, from anywhere they are, and then they can implement it in our on our robotic arm in our lab. Okay, so this is one of the current research that we are doing. Okay. We have also intelligent automated robotic arm for food industry. As you know, at the moment during this COVID-19, people are very concerned about their health and hygienes, and also the preparation of food. So having this intelligent robotic structure, we can actually create it, we can actually utilize the robotic arm to automatically bake a cake, for example, as the most difficult cake is actually what we have in Malaysia is called cake lapis Sarawak. It is layered by layer. There are 30 layers. I think in Indonesia they have this cake lapis, cake Betawi, I think. Okay, so there are layers of cakes need to be baked. So our robotic arm able to actually do these layers after layers of cakes with repetitive works, okay, in a very warm environment, okay, which is actually in a very hygiene situation that we is very important during this pandemic. Not only during pandemic, during any time we need our food preparation to be very hygiene, isn't it? So this is one of the recent research that we have conducted. We also have autonomous underwater vehicle that we utilize for remote monitoring and control, okay, to do ocean explorations, and also for tank cleaning. Okay, so our close collaborators, Runhill is actually one of the manufacturers of water treatment in Malaysia. So we are actually working together with them to do services for them to monitor the performance of their underwater, the water quality and all. Okay, so this is one of our very our consultation with industry that we have utilizing robotic structure and also artificial intelligence algorithm in it, okay, or for ocean exploration as well. The most recent that we are developing is what we call wireless water quality remote monitoring system. So this is also for our service for water treatment plant. Okay, so for example, around here just now, it is a water treatment plant where they need to actually monitor the quality of water so that when the water intakes coming to the water treatment, they want the quality to be very good, isn't it? If it's if it's contaminated with ammonia, for example, if they take it to their water treatment center, water from the river with ammonia, of course, it actually it can be detected in the water plant, but we want to detect it earlier. So in order for us to detect earlier, we need to put a lot of sensors in the water before the water can come to the plant. Okay, why is it so? Because we want it to actually, if, for example, there are something wrong, we are checking about the ammonia level, pH level, and turbidity. Okay, so if it's something wrong, we can actually do some controlling. For example, we can stop the water from coming in, or we can actually open the dam so that water will be flushed, the ammonia level will be reduced. So this is a very important thing. In the previous time, what we do is we do manual collections or regular collections using sensor. Okay, but however, the wireless remote monitoring is very, very crucial, because now people are being prevented from going outside, isn't it? So we still need to have a clean water coming to our house. So the water treatment plant have to be getting clean water. Okay, so to reduce the people engagement going out to the very hostile environment about this pandemic situation. So we have this what we call wireless water quality remote monitoring system, so that even though we are locked in our house, we know that the water quality is very good coming to our house. Okay, so I think that will be all that I would like to share during this short session. So I would like to welcome any questions from the floor if you have any question regarding my research. I'm Intan Darus. Thank you very much.
Okay,